What's up, calculus students? Let's do the 7-4 homework on the extreme value theorem, which refers to finding absolute maxes and mins. It's very simple. Any max or min on a function where we have a closed interval can occur at the location of a relative max or min, where the derivative equals 0. Let's pretend this is the graph of f. Here, f prime would equal 0. Really, it's when the derivative changes sign, not necessarily equals 0, or an endpoint. So if I close my interval, I can see I could start or end at a max or a min. But I also could have a max or min, overall max or min, when our derivative is equal to 0. So why does it care so much about endpoints? Because they could be locations of max and mins on a closed interval. Maybe the key word is the fact that we have a closed interval. Do we always need to check endpoints to find extreme values? No, not always. Let's say I had a sign analysis that was like this. And again, kind of in the lesson, we did like a start, some value where we change signs, and then an end. If I asked you for the location of the max, you don't have to check your endpoints. You don't have to kind of do much of an analysis to know that location must be the max, okay? We're going to talk about justifications and how we're going to explain things more next class. Right now, let's just find the locations of the max and min, and then we'll talk about the statements we need to write to justify things. Okay, now here's the key. When you're trying to find the max or a min of something, you need to take the derivative, set it equal to 0. Take the correct derivative. So like make sure you're looking at the correct layer. For example, if you want to find the max of f, I would then take the derivative, set it equal to 0, do my full f prime sign analysis. If I want to find the max of a position, I would take the derivative of position, set it equal to 0, do a derivative sign analysis. But if I wanted to find the max of a velocity, well, I'd have to take the derivative of velocity and do my second derivative sign analysis, which is my derivative velocity sign analysis, okay? So it's all about the derivative sign analysis telling us about the original function. All right, I have a position. I'm trying to find when the particle is furthest right or left. This gets translated to a max position, and this is a min position. So to find a max or a min position, I need to look at the derivative of position and its full analysis. I need the derivative of position. Set equal to 0, I get 3. I have an interval from 1 to 4. I have 3. I can look at the signs of my derivative. Again, if I plugged in like 2, I'd get a negative, then a positive. I know that my position decreases, then increases. And I'm asking you for when, but let's find when and where. So we always want our answers, especially for our test, to be in this form. That way, everything's clear. My position at this time is this, and that's the min. So I know I'm going to have a min at 3. Now, what's great about this example is that you have the position function. Okay, it's there. You don't necessarily need to do the next layer, though the next layer will be easily done when we find the 3 important positions. For example, I can plug in 1. Now, what are we plugging it into? Our position, not our velocity. This is very, very important. Maybe we're going to understand that for this layer, I'm going to be plugging in things into my position function, but this layer is the signs of my position's derivative or my velocity. Okay, so I'm plugging in 1 into position. 1 minus 6 plus 2 is negative 3. Plug in 3, I get 9 minus 18, which is negative 9, plus 2, which is negative 7. I plug in 4, I get 16 minus 24, which is negative 8, plus 2, which is negative 6. I make sure that these values make sense. Do I decrease? Okay, from negative 3 to negative 7, I'm decreasing 4. From negative 7 to negative 6, I increase 1. Doing this full analysis will help you for all of your free response questions where I could ask you about distance, I could ask you for overall displacement, but like we're good. We notice that we have a min here, and then out of my other two possibilities for my max, turns out that's the location of my max because it's the largest value. I start at a position, decrease 4, increase 1. I start at my max position here. So I'm going to write max is x of 1 equals negative 3. Min is x of 3 equals negative 7. Okay. Same thing here. Let's take the derivative and do a full sign analysis of my derivative. Great. I mean, crazy, but not crazy. We can figure this out. Two over root 3. Now, 2 over root 3 and negative 2 over root 3. Let's think about that. That's 2 over like 1.7. So that's close to 1. So it is definitely between 0 and 3, which is my interval. It's my start and my end. And I'm going to just go ahead and put it as 2 over root 3. Derivative, which is the 3t squared minus 4 equation. Position, which is the t cubed minus 4t equation. Signs of my derivative, understanding my positions. I'll understand my displacements. I'll understand the accumulations of my derivative. If I had a calculator, we could just start plugging in integrals into my calculator to find this level, which is the amount that I increase and decrease. All right, so if I plug in 0, I get 0. I might as well do a sign analysis. If I plug in 1, I'll get negatives and positives. So I know this is going to be the min. I'm just going to go ahead and start right off the bat. If I wanted to find that location, I don't want to find it. It's 2 over root 3 cubed minus 4 times 2 over root 3. Like, let's pretend we're getting ready for a free response question. We don't have to simplify. We're going to leave that. We'll call this just the min. My position decreases. This is going to be a negative number. And then really I just want to compare the start and the end. If I plug in 3 into my position function, I got 27 minus 12, which is 15. And we could see we're going to decrease some amount to get to a min. We're going to increase a much larger amount so that I get to 15, which is going to be bigger than 0, which is going to be the location when I'm furthest right, or it's the max. Okay, what these actual values are, probably, it's hard to do it by hand. It'd be easier to do it and get a decimal with your calculator if you had it. Now, careful. Still asking us when the position is a max or a min. I give you this question for a very specific reason. You got to understand what's given to you. You're not doing the same thing every single time. A position will be at a max or min when the position's derivative equals 0, really changes sign, or an endpoint. What is given to us? The derivative of position. You are given the derivative. You don't need to take a derivative. If you did a second derivative sign analysis or an acceleration sign analysis, you get a first derivative kind of understanding of increasing versus decreasing. This will tell you when velocity is going to be at a max or a min, but it doesn't tell you about position. So, like, this is very important. You don't have to take the derivative because it's already given to you. You just set your derivative equal to 0. You got 0, 4, and 5. Now, this is where accumulations are going to be important. This is the derivative, which is 3t squared minus 12t. What's my position? Oh, I have to take an antiderivative. We have to remember, if you don't have it, sometimes you have to find it. T cubed minus, I got squared divided by 2, which is 6t squared, plus c. The c is back, and that's okay. If ever we could find c, if I was given a position, I would want to find that c. It can only help with our calculations and help us with our understanding, but I don't have it. So this is going to be the equation I'm using for my position. And then my velocity equation is the equation I use for the derivative. So let's make sure we understand that. I think a lot of people are confused about what goes where. Have things labeled. This is f prime, this is f, this is x prime, this is x, positions. Okay, if I plug in 1, I'm going to get negatives. If I plug in 4.5, I'll get positives. So my position is going to decrease then increase. I can already tell x of 4 is going to be the min. X of 0, x of 5 could be the max. The only way I can tell is to kind of look at the accumulations. The only way I can look at the accumulations is to look at the positions, look at the antiderivative. I'll plug in 0 into my position function to get c. I'll plug in 4. I got 4 cubed minus 6 times 4 squared. I have to do this. 4 cubed is 64 minus 4 squared times 6, 96 plus c. 32, negative 32 plus c. All right, so this is negative 32 plus c. And then I'll plug in 5. $125 minus, that's 130. 25 times 6, 150. $125. Oh yeah, an extra 25. 150. So I have, did not give you the easiest position functions. 125 minus 150 plus c. So that's negative 25 plus c. Okay, great. Now, what's going to be the max? What's going to be the min? Well, we already know x of 4, which I'll just go ahead and put negative 32 plus c. That's going to be the min. Now, the justification for that is like my derivative is negative from 0 to 4, then positive from 4 to 5. Now, for my justification for which one's the max, which is going to be at 0, my justification probably will reference my accumulation from 0 to 4 being negative 32, and then my accumulation of my derivative from 4 to 5 being 7. And you could say, therefore, my position at 0 must be greater than my position at 5. Just by, you don't have to like really over explain it. Like you go down 32, you go up 7, you're going to end up lower than where you started based on that. So if you just are able to kind of reference these, not really including the C's and any justifications, rather just using the C's to find your accumulations, that's what we're going to be talking about. But we'll worry about that next class and making sure we have proper justifications for all of our questions for the next homework and for the test. Right now, let's just get the right answers. All right, same thing. Max min of position, we have a derivative. We have the derivative. We set it equal to 0. We have our sign analysis that has a start and an end. We have an interval 0 and 5, and we have this 3. Let's move this. Okay, my derivative goes with that. My derivative is, again, negative and positive. Trying to keep things consistent. It won't always be like that. Great. Well, you know, x of 3 has to be the min again. You know, the signs could be different, and this would be the max. But what's going to be the max? The only way I know the max is if I know an understanding of the positions. The only way I know the understanding of the positions is by taking the antiderivative. So my position function, x of t, which will be used here, is t squared minus 6t plus c. So using this position function, plugging in 0, I get c. Plugging in 3, 9 minus 18 is negative 9 plus c. Okay, that makes sense. I go down. And then plugging in 5, I get 25 minus 30 plus c, minus 5 plus c. Now you know about the accumulations of your derivative. From 0 to 3, you're going to have to subtract 9. From 3 to 5, you're going to have to add 4. That's how much you're going down, how much you're going up. If you go down 9, go up 4, well, you have to start from a higher point than you end. That's why this opening value is the max. It's not always going to be that case. It's just the examples that I give you, it happens to be that way. So x of 3, which is like negative 9 plus c, is the max. Justification would be the derivative's negative from 0 to 3, then positive from 3 to 5. You guys got to make sure you do your homework in its entirety for next class. And then the max is going to be at x of 0, which ends up being c. Your justification would be that your accumulation from 0 to 3 is negative 9, from 3 to 5 is 4. Therefore, 0 has got to be the max. T equals 0 is the time when we have a max. Because just like saying this shows you understand displacement, and then like it's assumed you understand why with those displacements, 0 is the max and not 4 or 3. All right, now read the question. When is velocity at a max or min? When is the particle traveling to the fastest to the left or fastest to the right? To find when the velocity has a max or min. Well, we need to analyze the derivative of velocity, which means we need an acceleration analysis. We need our second derivative sign analysis, x double prime. You are given x. Great. I need an x double prime sign analysis to understand x primes, maxes, and mins. We will look at the second derivative sign analysis. Oh, the second derivative in this case is 2. What the hell does that mean? Well, it means that x double prime, which is v prime, which is a, is positive. That means x prime, which is v, will be increasing. And my cursor comes back, I'll write that down. Now, this equation is 2. This equation is 2t minus 6. You know you can find your velocities at time 1. The velocity at time 1 is -4. The velocity at time 4 is going to be bigger than that. Again, this is not position. Why did I write that? This is velocity. My velocity, my derivative at 4 is 8 minus 6, which is 2. I go from -4 to +2. I have accumulated my second derivative to show that I've increased 6. Usually we don't include this step with our second derivative sign analysis, but it can be done. V of 1, which equals -4, is a min. V of 4, which is the other endpoint, is the max. We're increasing the entire time. Making sure you understand the accumulation of the derivative. The accumulation of this derivative is what tells you how much this is increasing. The difference between these values shows you how much you're increasing, how much you've accumulated. All right, same deal here. All right, it's really the exact same deal in that since I gave you x, after taking the second derivative, we realized the second derivative is positive on your interval 0 to 3. This is x double prime, which is v prime, which is a. That's positive from 0 to 3. That means x prime, which equals v, is increasing. That means v of 0 has to be the min. That means v of 3 has to be the max. We could find those if we wanted to. V of 0, v is x prime, of 0 is -4. V of 3, I keep doing that, it's like a habit. My velocity at time 3 is 27 minus 4, which is 23. I can see that I've accumulated my second derivative from 0 to 3, and I increased a total of 27. So I definitely ended higher than where I started. And we're good. Okay, second derivative sign analysis. Now what do I have? Okay, they're giving my first derivative. I'm trying to find the max and the min of my first derivative. I need a second derivative sign analysis. I need to take the derivative, set it equal to 0. V prime is a, it's x double prime. This is x prime, this is x double prime. The word for the rate of change of the rate of change's position is acceleration. I get the answer 2. I have a second derivative sign analysis, which will tell me about my first derivative's direction. X double prime, which is v prime, will tell me about x prime, which is v. If I looked at the signs, they are negative than positive again. I should have flipped some of the signs just to keep you guys on your toes, but I didn't. This is x double prime's equation, so that's where I got the negative and the positive signs from. This is x prime's equation, so this is where I'm going to get my positions, not really my positions, this is where I'm going to get my velocities, so I can know how much I decreased or increased. Again, this is without a calculator. So I got v of 0, v of 2, v of 5. V of 0 is 0. V of 2 is 12 minus 24, -12. So I've decreased. Again, I'm accumulating my second derivative to tell how much I decreased. These numbers should make sense. Make sure you have the correct thing here. I can see a lot of people always putting x prime, but this is x double prime. Accumulate your second derivative, you'll know how much your first derivative will increase. Need to plug in 5. 25 times 3 is 75 minus 60, which is 15. Okay, so I increased 1527. We're going to get our calculator out soon, so might as well warm it up. Double checking. If I accumulate from 2 to 5, my second derivative 6t minus 12, I should get 27. Ba-bow. Okay, now I found that value by finding the change in my velocities. So I know how much we're going up or going down. All right, so here v of 2 is the min. That's when I'm going furthest left. V of 5 is the max. That's when I'm going fastest right. Same deal. This is x prime. I want to find the max or the min of x prime. I need to do a second derivative sign analysis. Again, just like the first question, don't be afraid if your second derivative was just a positive number that's telling you that your your velocities are increasing. You have your velocity equation. This is what went into your sign analysis. This is what goes into your positions / your velocities. V of 0 is -6. V of 5 is 4. My accumulation from 0 to 5 of my second derivative must be positive 10. I increase 10. I have a min, then a max. I can look at the positions. All right. Now we go back to like day 2. That was really just like a day 3 repeat. Sometimes we have to use the antiderivative. We have to have plus c's. Even though we have plus c's, we can still understand motion. We can still understand like maybe not exactly where I start, but how much I go up and down. Accumulations. Now when I have a calculator, we don't need to take antiderivatives. In fact, we can't. These equations of the velocity that I'm giving you, you don't know how to take the antiderivative. So the whole like plus c thing, you can't really do. The only way we have to do this is to accumulate using your calculator. That can accumulate, does a lot of adding really quickly using a very complex algorithm. Add stuff up really quickly, accumulates your velocity. When you accumulate a rate of change, you understand how much your total changes. You understand how much you go up and down. So this is back to kind of like day 2 idea. Now, you are finding when you're furthest left or furthest right, please pay attention to the directions. We are finding a max or a min of position. Finding a max or min of position, we are going to look at the derivative equal to 0 or the endpoints. You are given the derivative. You are given the equation of the derivative. You need to analyze this. This is when we graph the derivative, which is given to us. We don't have to take a derivative. We don't have to do anything fancy. We are going to graph the derivative. We're going to graph y equals 0. Before we press enter, before we press graph, we're going to adjust our window. We're going to zoom fit. And guys, if you don't have a calculator, do this in Desmos at minimum. In Desmos, you can even type in integral, and the integrals show up. Like just go through the process of like making sure you're doing this. Even if you don't have a calculator at home, you can do this. All right, now what do I see? I see a lot, unfortunately. I see we start at 0. We have one intersection right here with 0, which I'm going to call A. We have one intersection right here, which I'm going to call B. And we have our end at 8. This is my derivative, and its signs are negative. We don't care about this minimum. This is where we're going to have like a point of inflection. This is when velocity is going to change from decrease and increasing. This is when the acceleration or the second derivative is 0, not an important point for this question. Between A and B, we have positives. Between B and 8, we have negatives. We have set everything up. Now let's find what the values of A and B are. We go second calc and intersect, making sure you have y equals 0 graphed. Enter, enter, enter. Write that down. Let's find the other one. Actually, let's store that as A first. That way we can use it. Let's find the other one. If you don't know what you're doing here, if you haven't done it, you got to go back and redo the lesson 2 homework, because this is exactly what we did in lesson 2. B is 5.8539816. Store that. Great. Now, we can't find the position function, but we do know a starting position x of 0 is 3, and we will use our calculator to find this layer, which are the displacements. The accumulation of the derivative tells me how much I'm going to decrease, how much I'm going to increase. I'm going to show all the work that you need to show. So let's go 0 to A of my derivative. Let's break out Mr. Calculator, 0 to A of y1. Make sure you put dx. And we can see we decrease 2.077. That means x of A equals x of 0 plus the integral from 0 to A of x prime, which equals 3 plus this number. You will need to have this kind of written down statement to show that you added these two values correctly together, and you get 0.922 ... because there's more going on. Don't round until your end. Keep this value in your calculator. We're going to use it. Now let's go ahead and go from A to B. Pull up your integral. Change it from A to B. $5.259. The number should make sense. It should be a positive number because it's how much we are going up. We have accumulated our derivative. Here, x of B will equal x of A plus this displacement from A to B, or the accumulation of my derivative from A to B. So I have the 0.922. I will then add this positive value. I get 6.182. Then I know that my position is going to decrease. Let's find out how much it decreases by finding the integral from B to 8. Accumulate my derivative to figure out how much I decrease or increase. Let's go from B to 8. And I decrease 5.729, which is a little bit more. So that means my position at 8 equals my position at B plus B to 8's accumulation of my derivative. Take my position at B, add this position here, the displacement there, and I get 0.453. All of these numbers should make sense if you look at them like one after the other. 3 minus 2, okay. Plus 5, all right. Minus 5, okay. This number makes sense. This is how we can find positions when we can't take the antiderivative. We can accumulate our derivative. Now we have x of 0, which is 3. A, B, and 8. We have all of our candidates listed off. We got to pick the smallest and the largest one. We notice that this is the minimum position value. It's the minimum of my candidates. It's going to be my minimum position on my interval. This is the largest of the values. This will be my maximum position. This is all that you have to do with this situation, you have to do your full sign analysis, and you have to do an accumulation analysis because you can't take the antiderivative. All right, let's switch it up and repeat 3 more times. Let's hope we don't have multiple sign analysis or multiple sign changes again. And I bet you I gave you another one. You gotta type in your derivative correctly. Adjust your window. If you press graph really quickly and you're like, oh, bad window, press on. Go back, adjust your window, on pauses. I don't like what I'm seeing already because I think I see a little, yep, there's 1, here's 2. Don't give me 3. All right. So, annoying, Mr. Messenger, that you did this to us. We have an A. We have a B. We have an end. I don't know, like, which area is going to be bigger. So I have no idea where we're going to end. Like, I could find these accumulations and compare them and then be like, oh, I know my answer, but I got a small little negative interval, then positive, then negative. And again, I'm using my derivative. I'm looking at the signs. I have these 2 intersections at A and B. Let's go find them and list them off. This is B. I got to store this as B. B equals 1.9892214. Go into my home screen. Let's store that as B. Great. Let's go back. Let's find A. Go up to your Y equals 0, so it might be quicker to go over. Enter, enter, enter. A is 0.145. Let's make sure we store that. Okay. Now, heads up, we're going backwards. We have x of 4 equals 3. This is going to be my position function. I don't have a position function. I'm going to have to find my accumulations. And I'll go backwards. So let's start from B to 4. Let's find this amount that we decrease, which means it'll be like a positive amount that we add to figure out where we came from. So we're all good. Let's store this as A. Let's start finding some accumulations of my derivative. Extra layer, really the only thing that's new in this unit is this understanding. So pulling up my integral from before, I have everything that I need. I got y1, I've already changed it. I've changed a and b, so we're good. All I need to change is b to 4, and we will be using our new equation. We'll be using our new b value, and we see we got this negative 8.148 ... number. That means x of b, and you got to write this for your test, will equal x of 4 if I subtract 8.148 to get to 3. That's how much I decrease. I need to subtract that negative number from b to 4. So I'll take the ending position 3, subtract that negative number to know that I'm coming from 11.1489 ... So there's x of b. But that number's stored. Now let's find the accumulation of my derivative from a to b. Accumulate your derivative. You'll know how much your original function is changing. Accumulate your feet per second over your interval of seconds. Feet per second times seconds are feet. This is important. Maybe you forgot why accumulating derivatives gives you change in totals, but think about it. It's like I'm adding up velocity times time. I'm adding up feet per second times seconds. I get feet. I'm multiplying 2 things together. Boom. Y's per x times x's give us y's. That's it. All right, so this is 9.009. That's how much I'm increasing. Now, if I want to find my position at time A, I'll take my position at time B and I'll subtract that accumulation. So I have my position here. I will subtract instead of add because I'm going backwards. And I get 2.139. Great. Then let's figure out my displacement from 0 to A. Negative 0.343 dot, dot, dot. If I want to find my position at time 0, I'm working backwards. I have my position at time A, and I subtract 0 to A, this number here, which means I will add because my position decreases. We'll double check to make sure all the numbers like line up and we're good. I have my position at A. I will subtract this number and I get 2.483. This is a lot more efficient, I think, the way that I did it here compared to the way that I did it on the the day 2 homework. Okay, let's make sure it works. 2.483 minus a little bit. Okay, 2.13. Add 9, 11.489. Subtract 8, 3. Boom. Who's the winners? Here are all my candidates. There's my min. There's my max. Position. All right, Mr. Messer, come on. Just give me one sign change. Don't do this to me. I think I'm giving you 2 sign changes because on your test you're going to have 2 sign changes. Let's be real here. There's going to be 2 sign changes here. I know because it's like sine t. It's got 0 and pi. Darn it. Just like the other homeworks, I'm skipping the free response at the end, you know? If you didn't do the previous ones by yourself, can you do this one by yourself? You know? Did you pause? You paused right now? Great. Well, doesn't help you. It's a little repetitive. We kind of crushed it, but it's important. That's pi. That's 2 pi. Oh, yeah, why don't I just like end it at 6 instead of at 7? Yeah, that's 2 pi. I'll store anyways. I forgot to store B, A. Just to remind you, after you find the intersection, don't forget to store it. This intersection, which is pi, don't forget to store it. Okay. I have x of 7 is negative 2. I need to find some accumulations because I can't take the antiderivative. Let's work backwards. Let's go b to 7 first. Where's my integral? There it is. B to 7. (1.662). X of b will equal x of 7 minus this accumulation. I should have dt here, but like they actually don't care on the AP exam, so. All right, Since I increased to get to -2, I must be coming from a more negative position. X of A will equal x of b minus the integral from A to B. Don't go B to A. Make sure you go A to B. If you go B to A, then actually you would have to add, because going from B to A actually brings you backwards. It will be an opposite value as A to B. Order matters. That's important. I'm sure we've all run into that, but we always go, and I forgot to kind of mention, we go from like the start to the end, a smaller to a bigger. If you went in the opposite direction, you get the opposite of what you expect, which we'll talk about more next unit. I expect a negative number because my position decreases. So this number here better be negative. If it's a positive, you typed it in wrong. X of B, that number minus that negative number adds it as a positive. Okay, let's go 0 to A. It's just pi. That's cool. Yeah, the area under one hump of sine ends up being like 2. I know what x of A is. It's 5.761. I know the accumulation of my derivative from 0 to A is pi. I will take that, subtract that to figure out where I came from. Okay, does this make sense? Increase by 3, I got to 5. Decrease by 9, I come down to -3. Increase by 1.62, I get to -2. All right, we got it. So we have everything, including my other endpoint, x of 7 equals -2. These are all my candidates. Here's my max. Here's my min. Position, time, position, time, position on the x-axis. Come on, Mr. Messner. Please tell me one sign change. Who made this homework anyways? What are you trying to do to us? Zero to 3. Zoom fit. Big money, no ways, no ways, no ways, no ways, no ways. Yes. Thank goodness, right? Come on. What are we even doing here? Huh? Calculus. We're doing calculus. We're doing calculus. That's what we're doing here. 0, 3, an A value is it. What's A? Second calc. Intersect. Enter, enter, enter. Man, if you guys can't get this right after doing these great examples that are very necessary, then you didn't really do your homework, and then I'm upset. But like, let's do well on this test. I'm really getting you prepared this year. I've changed things up from previous years to hook you guys up. My position increases, decreases. I have a position at time 0. I don't know the position function. I can't take the antiderivative, but I have my calculator and I can find some accumulations to know how much I'm going up and down. So we got that. If I do 0 to A, it should be a completely different number than 3.14. I didn't store the intersection. Come on. X store as A. There are some people out there, it's like, Mr. Messer, you didn't store the intersection. Yeah, be careful out there. There we go. 4.164. That means X of A equals, you gotta show this, X of 0 plus the accumulation of my derivative. I start at -4. I increase 4.164. I'm going to be at 0.164. Let's find your accumulation from A to 3. And that's it. -3. X of 3 equals X of A plus the accumulation from A to 3 of my derivative. It's a good example. Maybe if we wanted to just find my ending position, we could have done this quickly. We got that. We add that. Bam. -2.952. Does this all make sense? We're going to check. -4 plus 4, 0.164 minus 3, -2.952. All right, so we got these candidates along with my starting point. We got a min, we got a max. Min's at an endpoint. Max, we knew this was going to be a max. Yo, double check. Couldn't we just go 0 to 3? Boom. And add that to -4 to quickly get my end. If I just wanted my end, yeah, make sure we understand. Don't have to step it out with every single 0 at a time. Your calculator can accumulate all of your derivative over the entire interval, which is how you could get an end quickly. All right, these should be easier. If you just know what, I probably should have done this earlier. If you know what you just did, then you're good. So we'll just zoom past these. I got positives. I got a 0 at 3. I got negatives. I got a 0 at 5. I got positives. Remember, this is the graph of the derivative. What is the question asking? Furthest right, furthest left. I need to find a max and a min of position. How do I find a max or a min of something? I'm going to look at when the derivative equals 0 or an endpoint. When does the derivative equal 0? Oh, here's the derivative. Here's when the derivative equals 0. Not here, not here. When the derivative equals 0. So 3 and 5. I have my position must increase, then decrease, then increase. I don't have the equation. So I don't know like what my exact positions are, but I do know an initial position. And I do have the displacements from 0 to 3. I'm plus 5 from 3 to 5. I'm minus 3 from 5 to 6. I'm plus 1. So I got x of 0 equals 2. You'll have to show this. X of 3 equals x of 0 plus integral from 0 to 3 of x prime. 2 plus 3 is, 2 plus 5 is 7. X of 5 will equal x of 3 plus 3 to 5 of x prime. From 3 to 5, I got minus 3. That means x of 5 is going to be 4. X of 6 equals x of 5 plus integral from 5 to 6 under x prime. I got this 4 plus 1. I get 5. I go from 2, up 5 to 7, down 3 to 4, up 1 to 5. We're good. Shows us how much we're increasing and decreasing. We have a max. We have a min. Time, position, time, position. All right, they tell me x of 3 is 4. I'm going to 4. I start at 1. I got 0. I got my derivative equaling 0 at 1. We got negatives. We got positives. We got negatives. I got accumulations of -2, of 6, of -3. I got this value right here. That means since x of 3 equals 4, x of 4, I'm going forwards, will be x of 3 plus 3 to 4. And that's going to be 1. If I go backwards, I need to subtract x of 1 will equal x of 3 minus this 1 to 3. This is 6. Subtract 6, I must be coming from -2. -2 plus 6 is 4. Good. And then x of 0 will equal x of 1 minus integral from 0 to 1 over x prime. -2 minus -2, I must have started at 0. Does this make sense? Your starting position is 0. Subtract 2, I get 2. Add 6, I get 4. Subtract 3, I get 1. Good. This is correct understanding of decreasing and increasing and decreasing and how much. I ask you now about absolute maxes and mins, and we can find it because of our understanding of accumulations of derivatives. I'm done. I'm not doing these. Not doing them. Not doing them. That was long enough. We will do all these free response questions for your homework next class, and we will talk about justifications and what they ask you to do to justify what you're going to be like, gosh, this is a lot of stupid writing. And it's like, yes, it is. We're also learning one extra new thing next class about averages. All right. We'll see you out there.